Today's session objective is zener diode, reverse saturation current, zener and avalanche breakdown. After completing this video, you are able to understand what is zener diode, reverse saturation current and zener and avalanche breakdown. Okay, let us begin the today's session with the zener diode. Myself Lata Kulkarni, Department of Electronics, Maharani Science College, Mysore. What is zener diode? Till now we know what is diode. What is diode? Diode is a two-terminal semiconductor device. What is zener diode? Zener diode is also a diode. Basically it is a diode, but it is heavily doped silicon or the germanium PN junction diode. So what I told? First, zener diode is nothing but it is a diode, but it is heavily doped with the silicon or the germanium, and it is always operated in the breakdown region. It is always operated in the breakdown region. And here what happens, current is limited both by the external resistance and power dissipation of the diode. And in the construction of the zener diode, silicon is preferred because what happens, it's higher temperature and the current capability. Okay. So now let us move the physical appearance and the symbol of the zener diode. This is what the symbol of the zener diode. This is same as the PN junction, except here in the simple PN junction you are having only a single vertical bar, whereas here we are going to see one Z like symbol is there. Okay, and this term is the anode and this term is what your cathode, that is positive and the negative. Physical appearance, how you are going to see. Okay, this is what your physical appearance. Remember that this black side is what you are seeing, no? This is cathode of the diode and nothing is there, no? This is positive of the diode. Okay, this is the physical appearance and the symbol of the diode. Next, let us study what do you mean by reverse saturation current. Okay, when this diode is, when in the diode what happens, current is flowing through the zener diode increases dramatically to the maximum circuit value, which is usually limited by the series resistor. And when once achieved this one, no, this reverse saturation current remains fairly constant over a wide range of voltage, and thus that voltage is called the reverse saturation current. So let us revise. What do you mean by the reverse saturation current? Means the current flowing in the zener diode is increases. When it increases and it reaches some maximum value. Okay, actually this current is limited by the one series resistor in the zener diode, and when it reaches one maximum value, then what happens, that reverse saturation current remains constant. Okay, that current is called what, your reverse saturation current. Now let us move to the working of the zener diode. Actually, once again what happens, whenever we are calling about the diode means we are having the two biasing conditions. That is, one is forward bias and another one is the reverse bias. In the same way, here when the zener diode operates in the forward biased, all of we know what is forward biased. Then what happens? It just acts as a normal diode only. Okay, the same thing or the same graph we are able to get when it is forward biased. But what happens when it is reverse bias? Okay, when it is connected in reverse bias, a small leakage current flows through the diode. Okay, as the reverse voltage increases, it predominates the breakdown voltage. Current starts flowing through the diode. What is the meaning of this one means here? Actually, when you are applying reverse voltage to the PN junction diode, then what happens? This PN junction is increased. Okay, here also in the zener diode also the same thing happens. If the reverse bias applied to a PN junction, that is increased. The junction, that is PN junction. A point is reached when the junction breaks down and reverse current rises sharply to a value limited only by the external resistance connected in series with the junction. This critical value of the voltage is known as breakdown voltage. Okay, that is represented as V subscript BR. Okay, I hope you understood what do you mean by the breakdown voltage. Okay, let us revise once again. What do you mean by the breakdown voltage? What happens if the diode is reverse biased and we are applying voltage to that reverse bias? PN junction is increased. Okay, how much it is increased? Reverse current is sharply. Okay, what happens? Reverse current rises sharply to a value that is limited by the external resistance connected in series with the junction. This critical value is called the breakdown voltage. Okay, and when it reaches the breakdown voltage, what happens? If you increase a small amount of voltage, then there is a large amount of increase in the current. Okay, because at that stage what happens? It almost offers the zero resistance of the diode. When resistance is equal to 0, current is very, very high. Okay. This is about the working and the breakdown voltage of the zener diode. It is very, very important. Okay. Depends on this breakdown voltage what happens. There are the two types of the breakdowns are available in the zener diode. One is the avalanche breakdown, another one is the zener breakdown. Okay, what do you mean by avalanche breakdown? Avalanche breakdown is usually occurs in both the zener diode and the normal diode with a high reverse voltage. Okay, you see here what happens. So first let us study the avalanche breakdown. Actually, what do you mean by the avalanche breakdown means? When the high value of the reverse voltage is applied to the PN junction, the free electrons gains sufficient energy and accelerate at high velocities. Okay. So already we know that high reverse voltage is applied to the junction. Then only we are able to get the avalanche and the zener breakdown. So what happens when you applied the high voltage to the PN junction? Okay, the free electrons which are present in the diodes gain sufficient energy and accelerate at high velocities. Okay, next what happens? These high velocity electrons are there, no? They are moving and they collide each other and knocks off more electrons. Due to this continuous collision, a large number of free electrons are generated. As a result, electric current in the diode is rapidly increases. Okay. What happens? These high velocity electrons are moving and collide each other. Due to this continuous collision, a large number of free electrons are generated. As a result, what happens? Electric current of the diode is increases. This sudden increase in electric current may permanently destroy the normal diode. If the normal diode is there, means what happens? So if you apply, just if you want, you can try. Okay, if you apply more voltage to the diode, then diode is going to destroy. But it is not happened in the zener diode, because this diode is designed to operate under the avalanche breakdown and can sustain the spike of the current. So initially what we told, this zener diode is heavily doped, we told. So why? Because we are designed like that it should withstand that voltage and it should actually achieve this avalanche breakdown. Okay. So next what happens? Actually avalanche breakdown occurs in the zener diode with the zener voltage is greater than 6 volts. When this voltage is greater than 6 volt, then we are able to get the avalanche breakdown. So another important point about the avalanche breakdown is this form of the breakdown occurs in the junction. Here that the junction is lightly doped and a wide depletion layer where the electric field is not strong enough to produce the zener breakdown. It means that when the depletion layer is lightly doped, then we are able to get the avalanche breakdown. Opposite of this, that means our depletion layer is heavily doped, then what happens? It is a narrow depletion layer, then we are able to get the zener breakdown. Okay. So here you see, when the applied voltage, reverse bias voltage reaches closer to the zener, the electric field in the depletion layer gets strong enough to pull the electrons from their valence band. The valence electrons that gain sufficient energy from the strong electric field of the depletion region breaks free from parent atom. Yet the zener breakdown region, a small increase in the voltage results in rapid increase in the electric current. Okay, so here what happens? If the breakdown occurs in the junction, being heavily doped, have a narrow depletion layer. And next what happens? This breakdown voltage sets up a very strong electric field, that to about 10 to the power of 8 volts per meter across this narrow layer. This field is so strong that enough to break the covalent bonds, thereby generating a electron hole pair. Even a small further increase in the reverse voltage is capable of producing a large number of current carriers. Okay, therefore, what happens? This junction has a very low resistance in the breakdown region. Okay, this is about the zener breakdown and avalanche breakdown. And this is the VI characteristics, and it is showing the zener and the avalanche breakdown. Okay, so this is the forward characteristics, and so here it is going to show you the forward characteristics and the reverse characteristics. The forwards are characteristics, whatever you are saying, it is same as our simple diode, but there is a lot of difference in the reverse bias. What happens in the reverse bias? We are going to see the two breakdowns. That is one zener breakdown and one avalanche breakdown. So important point, you remember that zener. So first you should know what is the breakdown voltage, and afterwards you should know what is zener breakdown and what is avalanche breakdown. What is the breakdown voltage? Just if you want to, I want to revise means what is the breakdown voltage? The voltage in the reverse bias, what happens if we start increasing the voltage, then what happens? There is increase in the PN junction. So when the PN junction increased, okay, on some point what happens? It reaches the maximum current. So then what happens? Actually, if it is a simple diode means that junction is going to destroy. But because of this PN junction, what happens? This reverse current is very sharp, and this reverse current is controlled by the external resistance connected in series to that junction. Okay, and actually what happens if the junction is heavily doped, then we are able to get the zener breakdown. If the junction is lightly doped, then we are going to get the avalanche breakdown. Okay, please follow the video once again for better understanding of the avalanche and the zener breakdown. Okay, so this is the summary. After completing this, we understood what is zener diode, what is saturation current, and what is zener and avalanche breakdown voltage. Okay, please go through the videos again and solve these MCQs. Okay, thank you.